The dog doesn't hunt. And anybody who questions it as a crackpot, I'm done with this, Joe. Like, you want to come at me and say Eric doesn't know what he's talking about? I'm debating physicists. I'll debate anybody with the possible exception of Ed Witten, who still scares me, but I'll probably debate him too. In an open forum, we have got to purge the physics community of its quackery. And the quackery is coming from the high prestige version of this. The high prestige version of anti-gravity is called quantum gravity, and it just doesn't work.
So geometric unity is more of a complex topic. I'm going to try and break it down into terms that people can understand using the Joe Rogan podcast that he was on, where he was going through and explaining it. I'm going to explain it hopefully a little bit better, add a little intuition in ways that people can hopefully understand. One of the problems with regular orbit is just the idea that two objects are attracted toward each other and centripetal force is the only thing keeping them apart. Like, if you even dropped a sand grain in front of one of these things, that would really throw it off. But if you had something like this, imagine there's a positive charge and there's two negatively charged particles. Now, if this particle starts to edge in any direction, it's going to repel this particle, forcing it in the opposite. So if this one goes this way, that one's going to want to go this way, but it's still attracted toward the center part. So they're going to continue to spiral around. Now, this is kind of how the Coriolis effect works, but it works with more of a mass and a direct force relationship than with charged particles.
I don't know, 5 years ago, and I was doing this riff on the twin nuclei problem. I said, we've got to get off this planet. I said, we now become gods, but for the wisdom. And I just threw it off. And you said, focus on that. That's a great saying. Turned out to work.
One of the twin nuclear problem I noticed is just from the fact that, like, if you look at H2O and you're like thinking to yourself, well, if we're going to have balanced water, which is what we should have, and there's a positive minus state for the hydrogen, then why is there only a negative 2 state for the oxygen? Where'd that positive 2 come from? You'll see in some of these examples that I'll just assume that there is a positive negative 2, and I'm going to show you how that connects to the light future cone, how that also projects to basically like black holes in orbit.
Here's what's really happening. We do not live in space-time. This place is not in space-time. There's a saying, the map is not the territory. Space-time is a map, but the territory is wherever we actually live. And space-time has so many limitations on it that Newton never placed. So the longer we stay with no advancement in the general theory of relativity, the more we feel that we are imprisoned here. We're not going anywhere. It's all sci-fi. It's all garbage. It's children talking about things that aren't true. Well, bullshit. I'm now going to put on a different hat when you ask me about you, Eric, because people are going to say, crank, crazy, whatever. I'll meet you on the field of battle. Cut the crap, people. I am a post-Einsteinian person. I have not been in a relativistic context for years. And the reason that you get to leave relativity is that you recover relativity from another theory. If you have a theory that includes relativity, you can say, okay, yeah, I know how to see relativity inside the theory, but I can also see other stuff beyond it. And so that's where I work, in some place called geometric unity, because the geometry underneath the standard model and the geometry underneath general relativity is two different geometries called Riemannian and Arrhenius. I combined them. That was the point of it. In this thing, there's a very clear idea about how you would go about traveling great distances. And so I found that you still have this thing from the last time I was here 2 years ago. So this is a model of a space-time metric. And if you think about where these hair ties are on the two rulers, so this is the angle between...
For people just listening, there's an adjustable ruler with a sphere or a circle, rather.
So two rulers coming out of a protractor. And you can change the angle of the ruler. So whatever I choose this to be is 90 degrees. If I do it like this, that's still 90 degrees, or this. That's what an Einsteinian metric is.
Now, if you've ever actually seen the future and past light cone, you'll know it looks something like this blue end here. And as he's adjusting those points out, just imagine that he's actually adjusting these points out and making a larger or a smaller cone. And as the size of the cone changes, the angle is always going to be 90 between it and the actual distance between that and the central point. But depending on how large this is will actually affect the distance it has to travel before it intersects, before you get information from here. This will make more sense a little bit later.
This hair tie that I can move up and down is going to be the time measurement, like a watch. If you want to go a very long distance, one possibility is that you do something very energetically expensive. But the other possibility is grow the ruler to shrink the distance. If the rulers and protractors that Einstein used, and he chose one through his equation, are instead variables and you have full access to them. If I wanted to go a very long distance, the first thing I'd do is grow the ruler to shrink the distance, then go the distance under that ruler, and then I'd shrink the ruler back. Your friend who's had too much coffee believes that there are either 6 or 4 extra temporal dimensions, and whatever isn't temporal is spatial. So it's either 4 plus 6 or 6 plus 4 extra dimensions split between time and space.
I haven't had too much coffee. Unlike him, I believe it's a directly 6 extra temporal dimensions. And the reason why is because everything that I've seen shows that the dimensions are symmetrized. So the dimension of time always requires a dimension of space. And we can think about this in a few ways. First of all, anytime you detect an edge to decide whether or not something is 2-dimensional or 3-dimensional, it requires you to acquisition a point at an edge, acquisition another point at an edge. Those can't be done simultaneously. So that's going to be a time 1 and an acquisition point 1, a time 2 acquisition point 2. For you to know that it's more than 2 dimensions requires you to actually acquisition a third. Here's another way you can think about it. And here's how you can also think about 3 dimensions of time and space. So that'd be a total of 6 dimensions. Understand that whenever you're listening to music and you can feel that bass drop about to hit and you feel it in your chest, recognize that that is only existing because you can perceive the past, you can perceive the moment now, and you can perceive the future. If you were to perceive just one moment of time during that moment, it would just be like it would just be an utterance. But because you remember how the song led up to that, so that's the past, you're in that moment now. And because there's a future point coming up and you can expect it, it allows you to basically think or feel, is almost more like a feeling, 3 dimensions of time per 3 dimensions of space.
Another way to think in multiple temporal dimensions is to realize that anytime you've ever made a decision, it's been in 3 temporal dimensions. Like, let's say someone asks you if you want to do something and you decide, yes, you want to do it. In that moment, the now, you are projecting a future where it is good to do something. You projected it being good based on the past experiences. And so basically at any point in time you make a decision, you'll realize right here and then you're making a decision in the now based on something you perceive in the future, and that perception of the future is built on a previous perception, something that's happened in the past. Basically another 3 temporal dimensions. There's actually 3 temporal dimensions for just about everything. If you start picking at it, you start realizing that almost everything in the 3-dimensional realm or world has a third dimension of time that's correlated with it if you break it down to the process.
If that's true, try to imagine extra-dimensional engineers who have full access to something where there's no arrow of time. The only time there's an arrow of time is if time is 1-dimensional. If time is 2-dimensional, you have a whirlpool of time, which is either clockwise or counterclockwise. If it's 3-dimensional, you have a right-hand rule of time, and there's a left-hand rule of time. These are called orientations.
So imagine the right-hand rule, right? I'm using my left hand because it's going to reflect. But understand that if you wanted to understand the right-hand rule, consider like a whirlpool. Imagine at any point in time, you have something that's going in this direction. So it might be like in that direction. You also have the fact that it's moving in towards something. And then you have whether or not it's moving into or out of. For our perspective, that works pretty well. But usually we use it in like electromagnetic. So usually this might be like the flow of current. This might be like the actual magnetic field. And then this might actually be the force from the magnetic field. But it all works kind of the same way. So that's kind of the right-hand rule in like a layman's term and like help you understand how we use it in physics.
My belief is that we may be looking at something that has access to either 4 or 6 additional dimensions. And again, I'm reading this off of a page of equations and notes. And so you know what they mean in physical reality. In other words, if this thing on the page is true, holy shit. On the other hand, if it's just some geometry, then you don't worry about it. You say, okay, well, extra dimensions, I can think in 17 or 3 or what, it doesn't matter. It's not that hard to think in higher dimensions spatially for people who do what I do. Almost none of us can think in multiple temporal dimensions. Or for example, time and space, if I'm correct, the 14-dimensional manifold that has all the quantum going on it is split probably 7 and 7 dimensions because we have 6 extra time dimensions and 4 extra space. Add 6 to 1 and 3 to 4 and you get 7. So space and time are interchangeable. There's a duality between them. All of this stuff, our brain is not prepared for the idea that time is multidimensional. That was the whole point of giving Lex another watch. We don't have a way to think about, I'll meet you at 5:15 and 12:30, according to two different scales of time.
To think about everything in symmetrized temporal dimensions, I always also think about results. So if I'm meeting with someone in a moment in time, it's to discuss usually the past and project the future. So it's like, what are we going to do in the future? But what we're going to do in the future depends on what that person did in their past, what I'm doing in my past, and then we're going to talk about something in the now.
What would be the technology that would harness this?
You would figure out how to do the stuff on the record rather than the phonograph, the Victrola. You would start to move the space-time metric. You would move along the directions of the metric, not using the Einstein field equation.
So I'm going to explain to you exactly how I got that strobing light effect. What you'll see here is just a regular LED light, but what happens is, and you might see it on the screen, it's already flashing. What happens is when you go to dim a light like this, it has what's called pulse width modulation. Instead of burning off all that extra power, what we do is we turn the light on and off a set period of time. And so it's how basically most dimming lights and things like that work. It's actually just like a strobing effect. And so what I did was I went to my phone here, and if you have like a pro mode, if you want to see that better, what you can do is you can set the shutter speed to be a much higher speed, and I'll show you. So what you can do is you can set it to settings kind of like that. And so what happens is the screen looks dark right now because it's shutting so quickly, it's not really seeing much light, which is why that background looked kind of dark overall. And so what happens is you can adjust your ISO a little higher. So right now I have it at 125. What I'll do is I'll set it up to like 3 something, and you won't see the difference. All right, now that we got this going here, you can see that I'm recording. And so here, if I set my speed higher, see, and it gets darker. And if I set the ISO lower, then it'll get darker too. And so for whenever I wanted to see stuff like, I don't know if I showed in this one, but pictures of like space or something, what I'll do is I'll actually take a picture with this setting here. I'll have the speed, the ISO really low, and then I'll have the speed really long. This one actually, I guess because I'm recording, it's only going to be 160, but it'll go to like 20 or 30 seconds.